will be the acid-base disbalance, which is in renal. We'll be explaining what does it mean acid-base physiology? What does it mean acid-base disbalance? What does acidosis mean? What does alkalosis mean? By the way, since this is a new laptop, can you hear me clearly? Please write me on Telegram. Okay. Can you hear me now? Yes, I will repeat about the capillary permeability. Okay, good. So let me tell you a little bit about the capillary permeability. So somebody asking about something about medulla, something. I think I know what he's asking about. I think if I'm not mistaken, you are asking about the permeability of the tubules, like different portions of the tubules. So if you take a look at this graph, yes, this one, the nephron is subdivided into 3 sections according to its permeability to water, and it's subdivided into 2 sections according to its permeability to urea. Okay, so urea permeability is different from, just a second. So urea permeability areas are different from water permeability area. If we speak about this section of the tubules, so it's the proximal tubule, both the convoluted portion of the proximal tubule and the straight portion of the convoluted tubule. Both of these portions have really high permeability to water, because do you remember which substance we had a lot of reabsorption for in this area that likes water? Yes, it was sodium. And how much sodium do you reabsorb in the proximal tubule as a percentage? 70% of your sodium is reabsorbed in your tubule. That means most of the reabsorption happens inside of your proximal tubule. Those who missed the first class of renal, can somebody tell me how much urine do we make per day? I mean primary urine. Okay, I see somebody answering, but only one person. Come on, guys, we have 13 people in the group. Come on. Okay, yes, between 100 and 100 liters, 180 liters. And how much do we excrete? Because we filter a lot of primary urine, but the thing that gets excreted is minor. So yeah, it's around 1.5 liters only. Okay, that's good. So this area of your tubules is totally permeable to water, which means it can pass the water freely, and thus you will have a lot of reabsorption here. In this area, it's not permeable to water, but it's permeable to salt. So you need to be careful between these two. This is important. Why it is important? Because it helps in the creation of the gradient of the salts distal to the distal convoluted tubule. Something that we'll be speaking about when we reach the diuretics, which is the last portion of this chapter. Okay. So the last portion, which is your collecting duct, it's controlled by something called the antidiuretic hormone, also called vasopressin. So vasopressin, antidiuretic hormone, they are synonyms. They mean exactly the same. So these hormones, which are basically produced by which organ? Can somebody tell me where do we produce ADH? Antidiuretic hormone, where do we produce it? Typical mistake. It's not exactly, it's the hypothalamus, okay? It's the hypothalamus. So you produce it in the hypothalamus, but you release it in the posterior pituitary. You need to be careful about this because they love telling you, like playing with you around this. So this is your hypothalamus, let's imagine, and actually no, let's do it like this. So this is your hypothalamus area, and then it gives origin. This is your anterior posterior pituitary, and there is something like this. What happens in reality that you will have some connection of neurons tubules traveling downward like this. We call it the physial system. We'll speak about it in the endocrinology chapter. Anyway, so the ADH will be produced actually inside of your hypothalamus by some nuclei we'll speak about in neurology. And afterward, they will travel down the neurons until they reach your posterior pituitary gland, and there they will be released inside of your circulation. Okay? So, next thing. Yeah, so when you have ADH, you will have a lot of reabsorption of water. Can somebody tell me, please, what ADH lead to production of what in the collecting tubule? What reabsorbs the water? Which particle reabsorbs the water by the affection of ADH? Actually, the aquaporin. Exactly, aquaporin. These aquaporin are small kind of vesicles that collect water and bring it back. Okay, so more ADH, more permeability. Less ADH, less permeability. The next thing I spoke about yesterday was the urea permeability, which I told you they mention it on the exam itself. So if you see the all the way until the thick portion of the ascending lobe of Henle, it's permeable to urea. But this area, notice, this area, which is mostly located in the cortex, it's not permeable to urea. But they love to ask about this area. See this little area here? They love to ask about this one. They will tell you where is urea getting reabsorbed. And you have to tell them it's in the medullary portion of the collecting duct. So this is the collecting duct. It has a cortical region and it has a medullary region. So the reabsorption is happening at the medullary region. You must know this. Reabsorption of urea at the medullary region of the collecting duct. Okay. So let's speak today about acid-base disbalance, and after we finish with that, I will be telling you guys, going back to neoplasia, which is really important chapter. And hopefully we'll finish as much as we can from it. So today, I only want to finish the renal physiology with you, and hopefully afterward, I will be doing the neoplasia with you. Okay, so let's take a look. So we have the idea of metabolic acidosis, alkalosis, acidosis, alkalosis. So the primary question should be, what the hell is this? So there is something called pH. So what does pH mean? It means the hydrogen number. What? Well, here is what it actually means. So it means how many hydrogen particles are located in that area. And why this is important? Well, because our body as a human beings has a lot of hydrogen in it, yeah? And most of our body is actually made of hydrogen and carbon. That's actually it, hydrogen, carbon, we have some oxygen here and there and a little bit of nitrogen, and yeah, that's it. The other molecules are super minor in our body, but the hydrogen is a lot. Well, anyway, so if you have a lot of hydrogen, what is the big deal? If you have a lot of hydrogen, we say that you have acidosis. And if you have acidosis, that means you have a lot of hydrogen. So in that case, will the pH be high or low in case of acidosis? It will be low. In case of acidosis, the pH will be low. But a logical question need to be, since I'm having more H, I'm having more number, yeah? Why the pH is going down and not going up? Well, it's because it's actually because of something called the logarithm, okay? So when you have a number and you put in front of it in mathematics, you put log of that number, basically the whole number reverse. So the higher the first number will be, when you take its logarithm, it will be the lowest it can be, which means that if you have more hydrogen, like let's say 10,000, the logarithm of this 10,000 will be much lower. See, it's 4. The logarithm of 10,000 is 4. So that's if we imagine we have 10,000 hydrogen molecule. What about if I have 1,000? Look, you had 1,000, Now the logarithm is a 3. So as you can see, it reverses. And it's like logarithm in addition with one more thing. I don't want to get in details to mathematics, but you need to know that acidosis is a state when the pH is low, and the reason the pH is low is because you have a lot of hydrogen. And why is that happen? It's because of the algorithm, because of the logarithm. So anyway, speaking about acidosis, more H. Okay, I have more H. What is the importance of a lot of H? Why it can harm me? What are proteins made out of, from, guys? Proteins. Well, what are proteins made out from? Amino acids. Yep, amino acids. So you have one amino acids, another amino acids, another amino acids. And these amino acids themselves, if you Google the structure of amino acids, it's pretty interesting. You take a look at the structure. You don't have to know this for the USMLE, just for the sake of understanding. You realize, okay, it has a carbon-carbon, a lot of H's, yeah? A lot of H's, and not breakdown. Yeah, it has a lot of H's, yeah? So there is a lot of H's. Somebody writing not now. Can you hear me normally, guys? Okay, good. So a lot of H's, that means that a lot of H's can lead to basically, if you have a lot of H's and the environment around you have a lot of H's, these H's and these H's can get intimate with each other. And that will lead to destruction of your amino acids, which we call denaturation of your amino acids. Remember, any amino acids just have like these three structure for people in med school. You have the carboxyl group, the amino group, and the side chain. Side chain can be different from each amino acid and amino acid, but the original structure is the same in every amino acids. So when you have more hydrogen, basically, they can bind to this structure and denaturate it and destroy it. So in case of acidosis, you have destruction of the amino acids. That leads to destruction of the proteins. And enzymes are made of proteins. So you have denaturation of your proteins. So acidosis is really, really bad. Well, you are like, well, okay, so alkalosis seems to be the better deal. Well, it's not that good as well, because alkalosis itself, there will be not a lot of H's around, so he will start to steal the amino acid H's, you know? So that will also lead to problems of the enzymes of the liver. So as you can see now, we know the importance of having like the pH in a normal range. And if it was too high, it's a problem. If it was too low, it's also a problem. Can somebody please tell me what is a normal pH for a human blood? Human blood. 7.6 is too much. This is alkalosis. 7.5 for the USMLE is too much. This is alkalosis. Yes, this is for the USMLE. You must know it for the USMLE as a range. It is 7.35 until 7.45. You must know this number and be comfortable with it, okay? So the next thing you must know is this pH is in the blood. It does not mean that it's all over the body, because some areas tend to be a little bit more acidic, yeah? Normally, physiologically, like the stomach, for example. So if we take a look here, we have different forms of acidosis. So acidosis was subdivided into two portions, respiratory and metabolic. And the alkalosis, same deal, metabolic and respiratory. To make it simple for you, when we say respiratory, it's a problem of the respiratory system. But metabolic, it's a problem of which organ? The kidney, exactly. So this is why we are studying this topic in renal, since the kidney, it tends to be one of your most important systems controlling your pH. So, metabolic acidosis. So acidosis, you told me, in case of acidosis, the pH will be down. So what is the, again, from which part? Are you asking about the metabolic acidosis versus the respiratory acidosis? Okay, so if we speak about the metabolic versus the respiratory, The respiratory acidosis, it means a problem in the respiratory system, like in the lung, for example. While if we speak about metabolic acidosis, metabolic, it's a problem in the kidney, okay? So if the kidney is dysfunctional, you get some form of a metabolic disorder of your pH. But if the problem is in your respiration, you get some respiratory problem, respiratory pH disturbance. So let's speak about this. Let's say that we have a patient, and this patient has some form of metabolic acidosis. So the problem are in which organ? We said the kidney. In the future, as always, I give you an info, then I change it. So acidosis, metabolic acidosis in the future, that I will tell you, yes, it's mostly due to the kidney, but sometimes can be due to foreign substances. But don't worry about this now. Just for this paragraph, keep thinking about the kidney. Well, metabolic acidosis. So acidosis, the pH will be low, okay? And in case of acidosis, do you have more hydrogen or less hydrogen? More hydrogen, that's correct. Okay, so you have more hydrogen, so you have less pH. Why is that? If you have more hydrogen, you have less pH. Why is this happening? Yes, exactly. It's because of the logarithm. Okay, which basically reduces everything to vice versa. So speaking about metabolic acidosis, the pH will be low. You are completely correct. And, well, let's speak about the primary disturbance. Is it in the kidney or is it in the BCO2? Well, sorry, is it the bicarbonate, which is regulated in the kidney, or is it the BCO2, which is the carbon dioxide, which is controlled by the lung? In case of metabolic, which is wink kidney, the problem will be in the bicarbonate. Excellent job. So it will be the bicarbonate. So if you have metabolic acidosis, bicarbonate itself, forget about acidosis and alkalosis. Bicarbonate itself, is it an acidic molecule or an alkaline molecule? The bicarb itself. He's alkaline. You are correct. What about CO2? Is he alkaline or acidic? The BCO2, the CO2 is acidic. You must know this. BCO2 is acidic, bicarbonate is alkaline. So now you understand the importance of this. But for this moment, you need to know that the bicarb is alkaline. BCO2 is acidic. In a second, you will know why I told you this. So metabolic acidosis, the primary pathology is in the bicarbonate. Exactly. More BCO2 production will lead to more production of hydrogen. Correct. So in case of metabolic acidosis, the problem in the kidney, which means it's a disturbance of the bicarbonate, not the BCO2. So since it's a disturbance of the bicarbonate, you guys told me that bicarbonate is an acidic or an alkaline molecule. Tell me please again. Alkaline. Since it is alkaline, in case of acidosis, it will be high or low? It's an acidosis case, so logically, it will be high or low? Excellent, it will be low. So take a look here. See? So it's low. Why it's low? Because you have a state of acidosis. You don't want a lot of alkaline around. That's the primary pathology. Well, that's your kidney is saying it like acidophile. I saw that. Okay. So the bicarbonate, it has like will be much lower because of the absence of the well, acidosis lead to less bicarbonate. We are clear on that. Next note is about the BCO2. Well, imagine this, guys. You are in a state of acidosis and your kidney did that. The kidney did this. So your lung need to compensate for it. And in the future, you will see that whenever the kidney do a bad job, the lung compensate for it. If the lung do a bad job, the kidney will compensate to it. So they work with each other. So in case of acidosis, like metabolic acidosis, when I told you the word metabolic, it means the kidney did the problem. So who needs to compensate for it? The lung. So the lung, in case of metabolic acidosis, will it make more acid or less acid? Exactly, she want to kick the CO2 out. She want to make less acid. Remember when I told you that the CO2 was acid? So you want a less of it in case of acidosis. It's a compensatory mechanism. So the primary pathology will have the first word, metabolic acidosis. Or respiratory, the primary pathology, it will be in the BCO2. Metabolic, the primary pathology, it will be in the bicarbonate. So let's push it one step forward. So you have a high bicarbonate in case of metabolic acidosis. Your lung sense that, and she's like, oh, he has a lot of acid inside of our body, and we can control the CO2, which is an acid particle. So would you like to keep that acid particle inside or help the body and get it outside? They get it outside. Excellent. You want to get it outside. So how can you get CO2 outside from the lung? You need to do what? Ventilation. Exactly. You increase the ventilation. So hyperventilation, basically. So the compensatory response is immediate, and this is important. Remember, any lung response is immediate. And it leads to hyperventilation, so it can kick all of this PCO2 out. Okay, let's speak now about metabolic alkalosis. In case of metabolic alkalosis, again, let's start with the first word, alkalosis. Sorry, second word, alkalosis. Alkalosis, pH high or low? The pH is high, that's correct. And next thing, metabolic. Metabolic, is it a problem of the kidney or a problem of the lung? It's the kidney. But guys, I have a lot of people in the group. Come on, more people answer. Trust me, when you answer more, you get the knowledge much better. So the kidney is the one responsible for the metabolic problem. So metabolic alkalosis. So when you have metabolic alkalosis, the bicarbonate will be, it's alkalosis, we agree on that. So the bicarb molecule, is it alkaline or acid? Alkaline, excellent. It's an alkaline molecule. Okay. So in case of alkalosis, will it be high or low? High, obviously, because like it's metabolic, so it's the kidney, so that will need, and we know the kidney, it manipulates the bicarb, and thus this will be high. The bicarb will be high. Excellent job. Well, which lung compensate for the kidney when it basically causes the problem? Which organ compensate for the kidney when it makes a mistake? The lungs, exactly. Okay, so the lung compensate for it. Well, you have a state of alkalosis. Will your lung basically want to make more acid or make less acid? It want to make more acid. So if you want to make more acid, would you like to keep BCO2 in or out? In, exactly. You want to keep more BCO2 inside. Excellent. So how do you do that? By hypoventilation or hyperventilation? Hypoventilation. Excellent. Good. So you hypoventilate, less BCO2 is going out, so more BCO2 inside of your body. That gives you a state of acidosis. Okay? Logical. Excellent. So the next one, respiratory. Respiratory, is it a problem in the kidney or in the lung? It will be, yeah, obviously. Well, it's in the lung. So let's go to the next word, acidosis. So the pH will be high or low? Low, okay. So now we go to the next thing. It's respiratory acidosis. So the main problem will be in the CO2 or in the bicarb. It's respiratory. The BCO2, excellent. So in case of acidosis, we said the forget about acidosis. The BCO2 itself, is it an acid or an alkaline molecule? Yep, it's an acid promoting molecule, but for the sake of step 1, think about it as an acid molecule. Good. So respiratory acidosis, in that case, you will have more you will have more what? CO2. So more CO2, why? Because the kidney is controlling it and it's an acidosis. So here you go. See, it's high. Who will compensate? So now the lung is causing the problem. So who will compensate for the lung? The kidney, exactly. So the kidney will compensate for the problem created by the lung. Okay, so think about it. Is kidney a fast organ, or it has a lot of bureaucracy? Is it slow or fast? Yeah, super slow. Like it's boring. So this compensatory response by the kidney is exactly turtle. It's super slow. The kidney is super slow. So always it's delayed. In contrast to the lung, where the response is always immediate. Yeah? The lung is awesome. Lung works fast. Kidney is slow. And you will know why this is important in the future. I will be tricking you on a question like this when I will be telling you that, oh, look at this patient. He has like this form of like respiratory acidosis, and what's up with his bicarb? And you need to tell me it's normal because it was not a lot of time since it happened. Okay? So yeah, so you answered all of these correctly, but after a long time, really long time, what will happen to the bicarb in case of acidosis? Yeah, it will increase. Remember, it's respiratory acidosis, so the primary pathology was in the BCO2. So the response will be from the kidney by increasing your bicarbonate. And it was basically compensatory mechanism mediated by the kidney, and it was delayed. Respiratory alkalosis, now okay, let's see if you understood the topic. That will show. Respiratory alkalosis, it's alkalosis. What happens to the pH, high or low? Okay, so you are right, it's high. Okay, so it's respiratory. So the primary pathology, is it in the lung or in the kidney? Lung, okay, good. Next question, who wrote the kidney? Come on, it's respiratory. How can you make this mistake? Respiratory, it means respiration, it's the lung. While metabolic, it means the kidney. Again, lung, it's respiratory. Metabolic, it's the kidney. It's okay, don't worry about it. We'll get it right next time. So, respiratory alkalosis. So respiratory alkalosis, the problem is in the alkalosis, so the pH, as you said, it will be high. The problem is in the lung. And since it's an alkalosis, you will have more BCO2 or low BCO2. Remember, CO2 is an acidic molecule. You have a low BCO2. Excellent. And which organ will be compensating? The kidney. And it will be compensating by increasing the bicarb or decreasing the bicarb. Decreasing the bicarb. Excellent job. Okay, so you answered perfectly correct. All good. So the next thing I'm going to speak about is something called this Henderson-Hasselbalch equation. To be fair with you guys, they do not ask it. But for the sake of completeness, I have to explain it for you. And why the hell it's even here? They just want one thing from you. They want you to understand that the pH is controlled by two molecules. There is this weird formula, you should not memorize it, but you need to understand it. And it goes something like this. Your pH is controlled by two molecules. This is the first molecule, this is the second molecule. So it's controlled by your BCO2 and your bicarb, as you can see. And that's pretty much it. They want you to understand that it is controlled by your bicarbonate and by your BCO2. Okay? That's it. You don't have to know more than this about the Hasselbalch equation. Okay, so the next thing. This is super important. A predicted respiratory compensation for a sample metabolic acidosis can be calculated using the Winter formula. This is actually super important. I will explain it in a moment. So, in case of metabolic acidosis, which is the most important between all of these, for the sake of the USMLE. So, metabolic acidosis is the most important. Why? Because it can have so many subtypes. Okay? And one of the multiple questions they can ask about metabolic acidosis is it compensated yet or not yet? Or does the patient has only metabolic acidosis, or does he have metabolic acidosis and respiratory acidosis together? I know it's annoying, but you need to know if you have multiple pathology happening at the same time. Well, do you need to know all of them? In reality, no. You only have to know metabolic acidosis with respiratory acidosis if it's occurring. So how to do this? You need to calculate, well, you have a current pH, yes? And you have a patient who's having what? He's having metabolic acidosis. So our patient is having metabolic acidosis. And when your patient is having this metabolic acidosis, you are like, okay, so your pH is low, and your bicarbonate is low because you have metabolic acidosis and all of that. I get it. But is it only metabolic acidosis you are having? Are you having a concurrent respiratory acidosis as well? Well, because you asked, you must understand how to check your patient if he has both metabolic acidosis plus respiratory acidosis. To do this, you need to calculate the predicted BCO2. So, guys, when we speak about someone with metabolic acidosis, his lung will compensate. Since his lung will compensate, will the lung increase the BCO2 or decrease the BCO2 in case of metabolic acidosis? Okay, yeah, they will decrease it. They want to decrease it. Exactly. So they want to decrease it. They created a formula that can calculate by how much it will decrease it. Okay? And you will use that formula. And after using this formula, you will actually check the BCO2 of the patient. If your BCO2 that you have calculated is exactly the same as that was predicted, excellent job, no problemo. Okay? But if you do check the patient BCO2 and it's much higher than your prediction, it means that the patient has metabolic acidosis and what? His BCO2 is much higher than predicted, so that means he has respiratory acidosis as well. So two pathologies, not one. So predicted respiratory compensation for a simple metabolic acidosis can be calculated using the Winter formula. So the formula I was telling you about, it's called the Winter formula. And this Winter formula is actually super important. And it goes something like this. If measured BCO2 is higher than the predicted BCO2, see, there is, like we said, the BCO2 you measured, it's higher than the one you predicted. That means you have a respiratory acidosis as well. You have two pathologies, not one. But if your measured BCO2 is much lower, it's much lower than your predicted BCO2, it means you have a respiratory alkalosis. Let's take a look. So sadly, I know it sucks, but you need to memorize this one. You have to memorize this equation. This one, not really. Forget about it. This one, you must memorize. Okay, so how it goes? 1.5 multiplied by the bicarbonate. In case of metabolic acidosis, will this number be high or low? It will be low, yes. So 1.5 multiplied by the bicarb concentration plus 8 plus or minus 2. Okay, So if I have a patient that I did the winter formula on, okay, and his BCO2 was much higher, or like this is what I predicted according to the winter formula. And let's say that it was, I don't know, a crazy number, let's say it was 55. Let's take an example on it, for example 2. Yeah, well, let's do the 55. Come on. So 55. How much it should be normally? The normal bicarbonate, it's here. So we are speaking about acidemia. We are speaking about metabolic acidosis. So it need to be less than 20, okay? But I'm telling you now about the BCO2, okay? So I have my own way of remembering it. I don't know if you would like to use it, use it. It goes something like this. So you have it 20 and 40. Between bicarb and BCO2, which one of them is gas? The BCO2. So it flies up. So that's the 40. While the number lower is the bicarb. So this is the normal ranges. Okay, anyway, this is my way, but if you want, you can memorize what is written in first aid. I like my way. So the BCO2, let's imagine that it was here, the predicted one. Your predicted one was, in case of metabolic acidosis, you want to kick it out. So let's say it was 20, okay? But in reality, you found that the patient has it as 50. What does that mean? So the prediction said the 20, the reality said 50. What does that mean? Okay, excellent. He has a concomitant respiratory acidosis. Well, that's good. Well, if it was 20, if you calculated it as a 20, but when you checked in reality, it was something crazy like 10. What does that mean? Yep, respiratory alkalosis. Okay, good. So let's speak about the next point. So the next point, so now you feel, I hope you feel comfortable with the compensation stuff. We'll be solving some question about it after we finish with the whole session here. So, speaking about acidosis and alkalosis, your first step is to check arterial pH. And you told me, guys, that the norm was between 7.35 and 7.45. So this is the range. If it was lower than 7.35, it's acidemia. If it was more, it's alkalosis, alkalemia. So let's start with one section at a time. Forget about this area on the right. Let's focus on the left. So on the left, we have the acidemia. So the acidemia has the following. You have your bicarbonate, you have your BCO2. Well, first of all, you need to determine, is it the problem of the lung or is it the problem of the kidney? To do that, you need to check the bicarb and the BCO2. Well, in case of acidemia, what happens if the primary pathology was the kidney? What will happen to your bicarbonate in case of acidemia? It will decrease significantly because bicarbonate is an alkaline molecule, so it must decrease. Okay, so if we speak about a state of like respiratory acidosis now, respiratory acidosis. Respiratory acidosis, guys, what do you think will happen to the BCO2? Yes, since it's respiratory, it will be the BCO2, the molecule that will be harmed. Exactly, good. For some reason, this thing stopped working, so it's not moving. So let me exit just from it. Come on. Okay, did you work now? Well, okay, let's just try to finish this area, and then during the break I will fix it. So if we speak about respiratory acidosis, the respiratory acidosis thing, the BCO2 will be high. In case of really high BCO2, you cannot hear me? Can you hear me now? Okay, good. So if we speak about the acidemia, the respiratory acidosis, your BCO2 will be high. So a logical question will be why would I have a high BCO2? Well, it's some pathology of your lung. Your lung is not, you cannot see my screen. Okay, let me try to reshare that.
Welcome to VoiceOver. VoiceOver speaks descriptions of items on the screen.
Can you see my screen now? Please tell me it was not since the beginning. Okay, so let's see. Okay, so if we speak about the acid-base disbalance, if we speak about something called respiratory acidosis, so your main pathology will be in the acid, yeah? So your acid will be much more in your circulation. And if we say it's respiratory, it must be which molecule? The BCO2. You have a lot of CO2. Okay, so what leads to a lot of CO2? The thing that leads to a lot of CO2 is some lung problem, okay? So it must be a lung problem. For example, it's really famous for you, for them to tell you, it's a patient with a COPD, for example, okay? So COPD can lead to this is correct, and what else? Well, except COPD, any disease that make your lung dysfunctional will lead to it. In addition, not only lung problem can lead to this, also muscular problems. Why? Because if your muscles are not working efficiently, your lung will not be able to inflate and deflate, yeah? If that is the case, you will also get respiratory acidosis. So, hypoventilation is the main cause. And why we have hypoventilation? Airway, myasthenia gravis is one of the causes of muscular problem leading to respiratory acidosis. You are completely correct. Okay, if you have an airway obstruction, you are not able to breathe normally. So what will happen to your BCO2? It will go up or down? Up. So you will have acidosis or alkalosis? Acidosis, it's the lung. So it's respiratory or metabolic? Respiratory, excellent. Okay, so airway obstruction, acute lung injury. By the way, for airway obstruction, remember about this obstructive sleep apnea. So what is this obstructive sleep apnea? They love it. So that's why I'm explaining it. So obstructive sleep apnea, it's most of the time it's an obese male that is old, okay? And what happens actually that their airway is blocked by the base of their tongue. So they are obese. They have a BMI more than 30, and their tongue goes back, yeah? Yeah, well, that's true, but actually it will not be the patient who's complaining. You know who will be complaining to you? The person who will be complaining for you about this pathology is his wife. Exactly, his wife. Because it will be like, exactly, all night long. It will not let her sleeping. Okay, so it's because of the relaxation of the base of the tongue. Well, if they lose some weight, it get fixed. So it's not that's the solution. If they basically reduce their weight, it goes back to normal. But this constant obstruction all of the time will increase your BCO2, okay? And when you have a lot of BCO2, you will get a lot of problems. One of them is depression. You can get freaking diabetes. But the most serious one is hypertension, okay? You can sleep on your side and side or abdomen. Actually, by the way, guys, since we are during the COVID area, period of time, if someone has COVID, you need to keep in mind, they ask you, well, doctor, I feel bad when I sleep on my back. He's right. because when he's sleeping on his back, his alveoli are collapsing. Tell him to sleep in his abdomen while putting a pillow on his chest, okay? That will make him breathe much better because your alveoli will be stretched against the gravity, and that will make them open much better. So in a patient with COVID, let him sleep on his abdomen. Okay, let's go back to our topic. So, chronic lung disease like COPD and opioid sedation. Why opioid? What opioid? What can opioid do in your lung? Well, they decrease the respiratory rate, but not because of the lung. Exactly, they affect the respiratory center in the brain stem and thus lead to respiratory depression. When that respiratory depression occurs, you will have less breathing, more BCO2 accumulation. More BCO2 accumulation, you have respiratory acidosis, which make the BCO2 be more than 44 or 40 for the sake of simplicity. And to compensate for that, which organ will compensate for it? Kidney. Guys, by the way, since we are studying this in renal, which doctor do you think care the most about this stuff? Which type of doctor, specialist, which specialist care the most about this stuff? Like the acid-base disbalance? Anesthesiologist, exactly. And an anesthesiologist is the one who cares about all of these because he's responsible for this during the operation. If you get one of these messed up, you kill the patient. Okay, opioid sedation can also lead to respiratory acidosis. Okay, guys, now this is not moving and we almost passed an hour, so we will take a little break now for 8 minutes. I will fix this and we will come back. See you in 8 minutes.